Hello everyone. Today we are going to start the new topic from the paper Inorganic Chemistry, that is the paper number 1. Here the chemical bonding and molecular structures. In this chemical bonding and molecular structures, total topic are equal to 3. Which are the 3 topics? First is ionic bond theory, second is molecular orbital theory, and third one is the valence bond theory. Okay. Now we will discuss here. First part is about introductory part, that is introduction, how the bond is formed according to the Lewis. Second point is about valence bond theory, its only limitations, and third point is about the need for hybridization, its definition, okay, and requirements for hybridization. Okay, these points we have to discuss here. So let us start with the introduction point here. According to scientist Lewis, the covalent bond is formed by sharing of electrons. Okay. According to Lewis, the covalent bond is how is formed, that is the sharing of electrons within the atoms in a molecule. That is one electron from this, one electron from this, and this we have to share here, and there is formation of a bond here. This is called as a covalent bond. Okay. Now designation of this is dash bond like method. Already you know this. Okay. Now this bond formation takes place in two types of molecules. Which are these two types of molecules? First one is homolytic molecules, and second is heterolytic molecules. In homolytic molecules, for example, H2, O2, N2, that is known as a diatomic molecules. Okay, N2 molecules. Okay, and heterolytic molecules are which? That is formation of a NaOH, KCl, KOH, okay, KNO3 compounds. They are called as heterolytic. That is two atoms of an element are the different one. Now these molecules are called, that is these are called as diatomic molecules. Okay. Now as far as these homolytic molecules are considered, they are also called as a diatomic molecules. Which are also a non-polar one. Non-polar molecules. Okay. But in heterolytic molecules, in which they are called as here not a diatomic molecules, but the attraction between these two atoms of an element, they are called as a polar molecules. Polar molecules or compounds. Okay. Now the polarity is developed due to the difference between, that is delta plus and delta negative. Okay. These polarities are developed over the head of the molecules of an atoms due to the difference in electronegativity. Now what is the electronegativity? In last lecture we have studied about the definition of electronegativity. Again I am repeating this. It is the power of an atom to attract the species towards itself and becomes a negatively charged species, that is called as a electronegativity. Okay, that is due to the difference between the electronegativity, there is formation of a polar molecule of a bond. Okay, now this is about the introduction. Now how the need for the bond formation. In studying the quantum mechanics by the scientist, in studying the quantum mechanics the scientist Hitler and its co-workers while developing the quantum mechanics for the hydrogen atom, whatever may be they discovered the theory, that theory is put forward by Linus Pauling, and according to this theory, they have represented that the new formation of the theory, which is called as a VBT. That is, originally in studying the quantum mechanics for the hydrogen atom, first Hitler scientist found whatever may be theory, this theory is put forward by the Linus Paulings and Lewis, and they put forward the new theory in the form of a VBT. That is called as a valence bond theory, but it is of some limitations. Okay, now what are the limitations? First limitation is that it fails to explain the formation of polyatomic molecules. Second is, it fails to explain the paramagnetic nature of oxygen. Third characteristics is that is, it fails to explain the bond order, overlapping of orbitals okay, different types of geometries and so on. Okay, now these concepts have to be fulfilled and to be explained in the terms that is knowing to be, the term is known as the hybridization. Therefore the new term arises, that is called as the hybridization. It is the need for the hybridization is what here I am going to discuss. First is need for hybridization. Okay, some polyatomic molecules like here boron, beryllium, carbon, nitrogen, okay, oxygen, fluorine, some atoms in their geometries which are polyatomic ones, they cannot be explained by the old theory. Okay, there is formation of BF3, BeCl2, okay, then SO3, SF6. This formation we can't explain with the help of the old theories. Therefore, the new concept arises, that is known as the hybridization. That is in order to explain the overlapping of orbitals okay, their size, shape, their orientation in space, about its bond order, bond order, its geometry, all the criteria. In order to explain, we have to need the term that is called as a hybridization. Now the question is arises, what is meant by the hybridization? In the definition of hybridization, all the needs or the requirements for the hybridizations are in given. Once you know the definition of hybridization, you can easily write down the requirements or the need characteristics for this hybridization. So let us see the definition of hybridization as here. First is definition of hybridization. Definition of hybridization. Okay, now here it is defined as the phenomenon in which the mixing and recasting of atomic orbitals of nearly same or equivalent energies what I am saying to you, that is the mixing and recasting of atomic orbitals of nearly same or equivalent energies combined to form a new set of same equivalent energy, same kind of shape and equivalent energies of hybrid orbitals which are nothing but the hybrid orbitals are known as hybridization. Known as the hybridization. What is the hybridization? Again I am repeating this the definition. That is the phenomenon in which the mixing and recasting of atomic orbitals of nearly same or equivalent energies, here we have to go stress on this, which combine to form a new set of same kind of equivalent energies orbitals are known as hybridization, and the newly formed orbitals are known as hybrid orbitals. Now what are the steps or the requirements for the molecule going on the hybridization? See in the next point, that is the requirements for or conditions for hybridizations. Conditions or requirements for hybridization. First, there are totally 10 conditions. Okay, one by one we will see here. First, the atomic orbitals should possess similar shape. Okay. Second, atomic orbitals that is in short we can write it as AOs should be mixing and recast with each other. recast with each other. Third kind, number of atomic orbitals combined in the process of hybridization. Hybridization is equal to the number of hybrid orbitals newly formed. Here, one must characterize is that here first and last characterize is that is hybrid orbitals possess same shape and equivalent energies. Now we are going to explain this one by one. This is the first, second, third, and here going on a fourth one. What is the first requirement? That is atomic orbital should possess similar shape. That is whatever may be the atomic orbitals take part in the hybridization, they should possess the similar shape according to our definitions of hybridization. Second one is atomic orbitals, that is AOs, should be mixing and recasting with each other. This is the most important condition for the hybridization. Okay. Now, the number of AOs combined, if the number of atomic orbitals combined is equal to 4, that is in the process of hybridization, that is equal to the number of hybrid orbitals. That is whatever may number of atomic orbitals equal to 4, we get the number of hybrid orbitals is equal to also 4. Hybrid orbitals should possess same energy and same energy and equivalent shape. Okay. Now, next criteria is that is geometry of hybrid orbitals depend upon number of atomic orbitals taken part in hybridization. Okay, here geometry, bond order and type of hybridization. Hybridization depends upon the AOs and nature of the combining and its nature of combining. Okay. Now what is the next? That is the geometry of hybrid orbitals depends upon the number of atomic orbitals take part in. How many atomic orbitals can take part in this? That is, this depends upon this atomic orbitals. The number of atomic orbitals of S and P orbitals are takes place. There is formation of a sp hybridization. Bond order type of hybridization depends upon the AOs and its nature of combining. Now next points are given to you, that is are here. I am going to discuss with you. That is, firstly, resultant orbitals have resultant hybrid orbitals possess similar shape and orientation in space. And last one is the increase in percent of S character increases with the stability of hybridization. Stability of hybridization. Now what is the next requirement? That is, resultant hybrid orbitals should have similar shape and orientation in space. Also, increase in percent of S character. That is, this point we have to discuss in the points of electronegativity. Okay, that is, as the electronegativity increases, there is increase in percent of S character. That is why increasing percent of S character increases the stability of this hybridized orbitals and the hybridization. Okay, that is the type of the hybridization. In this way, we can conclude the requirements and or the conditions for successful overlapping of orbitals in hybridization. In this way, we will here discuss. We will discuss here, that is the types of hybridization in next lecture, and which are the types of the hybridization. Just I am going to look out on these types. See here. On the basis of the requirements for the hybridizations, there are the types of hybridization are as follows. Okay, which are the types? First is sp hybridization, second is sp2 hybridization, third is sp3 hybridization. Okay, hybridization. Next is dsp1 hybridization, dsp2 hybridization, and so on. D2sp3 hybridization. Okay. Now one by one, in next my video we will discuss about what is meant by the sp and sp2 hybridization by taking the examples of first is BF2 and second is BF3. I hope that all of you, if like my video, please share and subscribe the video. Thank you.